Hey, so I'm going to show you how I would create a product animation like this one from start to finish in Cinema 4D, Redshift, and After Effects. I'll show you how I work with the cloth and rigid body simulations, how I currently approach lighting for my scenes. I'll show you my render settings and even show you which AOVs to render out. So if you want to make specific changes to like the color of the cloth or the color of the bottle itself, I'll show you how to do that as well. But before I get started, I want to let you know that this video is sponsored by Skillshare. When I first took the plunge from photography into the realm of 3D, it was Skillshare that helped make it really easy, because it was on Skillshare where I took my very first 3D course. And now that we're approaching the end of the year, it might be a good time to start thinking about new skills that you could learn in the new year. I think I'll always be a Cinema 4D guy, but lately, I've been wanting to level up on my knowledge of Unreal Engine, because I never seem to stop hearing about it, and for good reason, and really want to see how it could fit in my work as a VFX artist. So I've been eyeing that beginner's class by Jordi Van de Put because I definitely need a refresher, and I'm sure that class is packed with good info and solid entertainment. Now, if you have no idea what I'm talking about, which is highly unlikely, Skillshare is the largest online learning community for creatives with thousands of classes led by industry experts across film, illustration, design, freelance, productivity, and much, much more. They even have some new improvements, which is the ability to find classes by software or material. New members are asked to share a little bit about their interests, and from there, Skillshare immediately surfaces recommendations tailored to their goals. They've also included 3 new class topics: creative careers, creative inspiration, and one that we've all been excited about, AI and innovation. So whatever skill you have or want to learn, Skillshare can help you take that skill to the next level. The first 500 people to use my link in the description below will receive a 1-month free trial of Skillshare, so take advantage and get started today. All right, so we're in a fresh Cinema 4D scene here, and the first thing I'm going to do is open up the asset browser. And in the search field here, I'm going to type in bottle. And when I scroll down here, there's going to be a handful of useful 3D models of bottles ready to go. One I ended up using is this one right here, so I'm going to double click on it, and when I do that, it will appear at the world origin like so. All right, I'm going to put this bottle in my geo folder right here and hide it, and I'll move on to setting up the cloth simulation. So I'll first insert a plane, put that in the geo folder as well. I'm going to press ND to show our lines, and I'll increase the size of this plane by about 100 centimeters. Not necessary, but just felt like doing it. Then I'll increase the segments by a lot. Let's say 150 by 150 segments should be good for now. Now let's start by adding a cloth simulation tag by going into Tag, Simulation Tags, Cloth. And in order to see how it's affected, I'm going to go up to Simulate, Forces, and grab a turbulence force and drag that into our Forces folder. Then under the object tag, increase the strength and the scale. And when I hit play, we should see the first fruits of our cloth. Okay, that doesn't look good. Not sure why it's doing that. I think if I place the plane underneath the turbulent force, that should fix it. There you go. Now it's working. Now, in order to have more control to this cloth, I'm going to add a vertex map. So I'm going to come up to Tags, Other, Vertex Map. First thing I'm going to try to target are the edges because I want to clamp those down so that it doesn't move when I simulate it. So I'm going to grab a box field, come into remapping, and we'll set the inner offset to 100% so that there's no fall off near the edges. Now I'm going to extend the size of this field so that it approaches just near the edge, but not past it. And a little bit more on this side. And there you go. I'll just bring this down a bit. All right, in the cloth tag, I'm going to go up to Mix Animation and turn on With Force. Set the strength to something like 10, and then drag this vertex map into that map field. And that should tell the cloth tag to communicate with the vertex map. So if I go ahead and press play, the edges are now staying put while the cloth inside is still affected by that turbulent force via the simulation tag. Now, there are pockets of the map being affected right here, so all I need to do is increase the size of the box field to fix that issue. All right, so now let's art direct this cloth a bit using settings in the tag. I'll go into the surface tab and set the bendiness to something like 100 and the stretchiness to, let's say, 60. Press play. And we can see a bit more folds in the cloth, which is nice. We can come into the turbulence and increase the strength and perhaps lower the frequency to about 75 and increase the scale a bit as well. Looks a bit more subtle and less chaotic. All right, next I'm going to control the areas where the cloth is affected by the turbulence force because right now it's being applied uniformly across the cloth. So in order to do that, I'm going to add a random field and we'll set it to subtract. Then I'll set the contour mode to curve so that in this curve I can clamp the values. Just like so. Then I'll change the scale of the noise by coming up to the field tab and increasing the scale to something like 750. That looks good. I can come back into remapping and adjust the spline to adjust the values to my liking. I think something like this looks good. And then lastly, I'm going to add some animation speed to it so that it's constantly changing. If I hit play, you can see the random field affecting the values on the map. So now, anywhere where this is yellow, the cloth is being affected by the turbulence force, and wherever there's red, it's clamped by the mix animation value in the simulation tag. Now, this looks pretty good, but I think we can add just a little bit more randomness, if that makes sense, by adding a rotational force. So I'll come up to Simulate, Forces, and select Rotation, and put that in the Forces folder. Now, keep in mind that this rotation force will rotate around the z-axis. So in this case, I'll need to rotate this gizmo so that the z-axis is pointing straight up. And there we go. Then I'll come into the settings and set the strength to something like 200 to start. And hit play. You can kind of see it, but it's not as apparent. So I'll increase the strength to something like 650. Okay, that's way too much. I'll bring that down to something like 250. And hit play. I think that's good for now. One more thing I can do to randomize the direction of the rotation force is use the new field driver system in C4D. With the rotational force selected, go up to Tags, Animation, and Field Driver. And now I can use fields to drive almost any parameter in the rotational force. In this case, I want to drive the rotation of the rotational force. So I'm going to click on Coordinates, Transform, Rotation, and Y. And we can set the min and max values that this force will be rotating, which can now be driven by fields. So I'm going to grab a random field and call it something like rotation random. Change the scale and then add some animation speed. Now, the direction of the force will be randomly oscillating. It's a bit small, so I'll increase the values to, let's try 270. Still not as strong as I'd like. Let's try 360. That looks good for now. The motion driven by that random field looks a bit too jerky, in my opinion, so I'll add a delay modifier to smooth out that motion a bit. And then I'll increase the angle speed to 350. And let's try 300. That looks good. Let's hide this random field and rename it to the same name. Rotation random. And drag it into the fields folder. I'm going to try to adjust the values of the force one last time. Strength to 150, scale to 50%, frequency just a little bit higher, and let's dial back the angle speed of the rotational force to 275. The last thing I'll add is some more wrinkles in the cloth by going into the cloth tag and increasing the target length just a bit to 113. And we'll drive this with our vertex map and hit play. Now we're seeing a bit too much of the geometry here, so I'll go into the falling tag and increase the angle to 180 degrees. And it's a tad bit too chaotic, so I'll reduce the rotational force down to 175 and the turbulence strength to 135. And hit play. I think that looks good. I think the cloth now is at a good spot. So let's next add our wine bottle and set up the rigid body simulation tag. I'm going to unhide our wine bottle. And I'll raise it up and rotate it like so. Now I'm going to collapse this group into one object, which will be important when I get to the camera animation, and overall we'll have less complications with the simulation settings. So I'm going to come down here and select Connect Objects. Then I can move this group into a hidden backup folder. All right, let's get the rigid body tag by going up to Tag, Simulation, Rigid Body. In this tag, I'll go into Collision and then set the thickness to 0.5, as well as going into the cloth tag and setting the thickness to something like 0.4, so that the collision between the cloth and the bottle are as close as possible. All right, so now that there's a simulation tag on the bottle, let's hit play and see what we have. All right, that's obviously not what we're looking for, but that's kind of fun. So we need a way to exclude that turbulence force from affecting the bottle. To do that, we can click on the rigid body tag and go down to Forces, set the mode to Include, and the force we're looking for is gravity. So I'm going to come up to Simulate, Forces, and select Gravity, put it in the Forces folder, and then drag this into the object field. Then we got to make sure the cloth isn't affected by this gravity force by coming into the cloth tag and dragging the gravity force into the cloth's object field under Exclude. And now when I hit play, the scene in general acts as it should, or how I imagined it would. Now to art direct this a bit, right now the bottle looks like it's sliding on the cloth a bit too much. So we can go into the rigid body settings and set the friction to something higher like 3. In the cloth settings as well, we can set the friction to something like 1. And then we want this bottle to look like it has some weight to it, so I'm going to go into the Mass tab and set the density to something like 2. Yeah, let's try 5. Okay, let's try 8. Okay, that's too much. It just goes right through our cloth. Let's bring it down to 5. Yeah, that looks good. All right, so the next thing to configure is the rigid body guide or shell, because right now, if I go into the simulation settings and turn on rigid body shapes, you can see what C4D actually calculates as its rigid body object, and it doesn't look too accurate to the shape of our bottle. Since I'll be rendering this relatively close up, we'd want to make sure that collision shape is as close to the bottle as possible. So to change this, we go into the tag, go into collision, and under collision shapes, we select triangle mesh. Without touching anything else and move one frame forward, see that the collision shape is much more accurate and dense. It may take longer to calculate, but in this case, accuracy is what I'm going for. All right, so let's turn off the collision shapes and run a simulation once more to see if anything has changed. Okay, so now it seems like our bottle got a lot heavier after changing the collision shape. So to remedy that, I'm going to go into mass and change the density down to 3 and see what that looks like. All right, that may be a bit too heavy still. Let's change the density to 1.75. Maybe still a bit too heavy. I'm going to bring it down to 1.5. Huh, still looks too heavy. The setting must be more sensitive than I thought. Let's bring it down to 1.25. All right, that looks good. Finally. I'm going to cache the simulation and then move on to setting up the camera animation. All right, let's drop in a Redshift camera. Setting the opacity of the safe frames to 100%. And then setting the focal length to 200 millimeters. After that, we're going to take this focus null and drag it into the object field under the optical tab. And then we want to make sure that this camera follows this wine bottle, obviously. So a way to do that is to first duplicate this focus null and call it something like cam target. Then add a target tag to the camera and place the cam target null into the target object field. So now when I move this null around, the camera follows. But now we need a way for this null to follow the wine bottle. So we can do that by adding a constraint tag to this null. Selecting transform, going into transform and dragging the wine bottle into the target field like so. You'll see the null snap to the bottle's pivot position, and when I hit play, you can see that the null goes wherever the bottle goes, and therefore the camera follows. The neat thing about using a constraint tag is now we can use this offset position right here to adjust the position, in this case, of that null. So in this case, I'm going to move the null in the Z about 13 centimeters. So now when I hit play, the bottle is better framed throughout the animation. Now notice how the camera is following the null a little bit too close, that the movement is now a little bit jerky. So another benefit of using a constraint tag is that we can adjust the strength of the tag. So if I set it to something like 70%, notice how the null moves, so I need to adjust it here to about 9 centimeters. And if I hit play, you can see the camera isn't as jerky as before. I think we can dial down the strength even more to say about 40%. And hit play. Yeah, the movement of the camera is much less jerky and much more fluid-like, which is nice. I'd say we can dial back the strength even more to say 25%. And adjust the Z position a bit as well. Yeah, that looks great. The last layer I'll add to the camera is some good old keyframes, just to add a little bit more organic movement to the camera. And I'll fast forward through this as I assume you know how to place keyframes. For the lighting, I didn't do anything elaborate. It was just a simple HDRI that I just rotated to fit the scene, and That was it. All right, so we're in the Redshift render view and I have a dome light in the scene. I'm going to hop into the GSG Plus library, and here I have a collection of user HDRIs that I picked up on my own. And I used this one right here. I'm just going to drag and drop it into the path field, and we should see the light update right here. From here, I'll come into the coordinates tab and just play with the rotation until I get something that I like. There you go. That looks pretty good for now. By the way, to get rid of these geometric lines, all you need to do is subdivide. I'll just go ahead and do it from the Redshift object tag. So I'm going to select the plane, and I have the Redshift object tag here, right here, so I'll click that. Go into geometry, turn on override, and enable tessellation. Yeah, there you go. Now it's nice and smooth. Now, before I move on, I just want to brighten the scene up a little bit because it's too dark right now. So I'll come into the dome light here and increase the exposure to, let's do 1. Yeah, that looks better. All right, let's move on to texturing. In GSG's Plus library, I used this white half circle cotton fabric material, which I thought looked nice. So I'll double click on that and it should show up in the manager. And when I drag that material onto the cloth, we should see it in all its glory in the render view. There we go. Now the scale looks a little bit too large, so I'll click on the tag and scale down the length to about 80%. Let's see what that looks like in the camera. And that still looks a bit large. Let's scale it down to about 40%. Let's try 45%. Looks better. Now, at this point, I want to add some depth of field, but I forgot to make sure that this focus null tracks the bottle just like the cam target did. So I'm going to run through the same process I did for the cam target by adding a constraint tag to the focus null, dragging the wine bottle into the target field and setting the offset to a position that works. So here's the camera's focus plane, and wherever that null goes, that focus plane goes with it. Let's hit play and see what that looks like. All right, so now I can hop back into the camera, open the render view, and add some depth of field. I'll set the aperture to something like f2 and turn on this bokeh switch to be able to see it in the render view. I'm going to zoom in the camera a bit more because right now it's a bit too wide. I think 250 should be good. For some quick effects, I typically like to add bloom before I render. So I'm just going to turn that on right here in the render view settings and adjust them until I get the look I'm going for. All right, so I think we're at a good spot. Let's move on to setting up the AOVs and render settings. All right, so let's close down this material manager and open up the render settings. Going to twirl these settings up. Go to Redshift and go to the AOV tab and open up the AOV manager. So one of the primary goals of AOVs, which stands for arbitrary output variables, is to be able to isolate parts of your scene so that you can easily edit or manipulate them in post. So for example, one of the parts of the scene that I'd want to be able to change after the render is the color of this cloth pattern. To do that, we need to go into the material itself and add what's called a store color to AOV node. Once that's in, we first need to plug in the material to the beauty input, and then we need to isolate the grayscale version of this base color node. So to do that, we need a ramp node. Plug that in. Then we need to plug the out color to this AOV input in the AOV node. Once that's plugged in, we need to add a name to this AOV by clicking on this dropdown and selecting Add New Custom AOV. I'll just call this Cloth Texture Color 01. Then I'll just plug this node into the output. Now, once we do that, if I go to the AOV manager, a new AOV is added to our list, which is the one we just made. And one note here, I typically like to have Cinema render out the AOVs from Redshift directly. So I typically like to turn off multipass and just select direct instead. And then click into the AOV and set the compression type to DWAB. Now, if you want to see what that AOV looks like in the render view, you can do that by hitting render and then coming into the material where the AOV is stored and using this solo button right here. Click that and the render view will pretty much solo that node. And since it's plugged into the store AOV node, this is what that AOV will look like as well. And of course, this being a ramp node, we can come into the ramp and clamp the values if we need, say, more white or more black values. All right, so I'm going to do the same exact process for the bottle and the labels, and I'll be right back. Okay, so we have all our AOVs. Let me walk you through my typical render settings. I'll first go ahead and set a location to where to save the files. And then we'll go into the AOV tab under Redshift and copy and paste the file name into this field right here. Make sure to save all frames. Go to motion blur and make sure I turn on deformation blur because we have deformation on the plane as our cloth. For the shutter, I typically just leave this as default. Globals, I pretty much leave everything default here as well. Here are my GI settings that I rarely ever touch. Under systems, I set the bucket size to 128 and the memory management to auto with 77% under the used GPU memory. And that's pretty much it. I'll let that render out and I'll see you in After Effects. All right, so I'm in a new After Effects file. The first thing I'm going to do is import our file. Before you import it, it's important to click on Open EXR Sequence and create composition, depending on your workflow, and click on Import. This dialog will pop up. I typically leave these checked on and hit OK. One last thing to change here is the color space since we are working in ASYS-CG. Change the color engine to OCIO. Click OK. In OCIO configuration, select ASYS 1.3 CG 1.0. For the display color space, I typically work in sRGB, but you can work in Rec 709 for a less contrasty look if you prefer that as well. And then for the bit depth, since I'm working with EXRs, I'm going to set this to 32 bits per channel. Then click OK. Now in our sequence folder, the first thing I'll do is right click on the main sequence, go to Interpret Footage, Main, and right here I'm going to change this to 24 frames per second. And then we're going to come up to Color, make sure Show All is ticked on, and then change the media color space to sRGB. And click OK. Now, one thing that happens when I import this way is all these pre-comp passes come in at 30 FPS. When in my main comp, I'll be working in 24 FPS, and it'll throw me off. So right now, I'm not sure how to import them at 24, so I'll just go into each comp and change them to 24 FPS. All right, so if I hop into the assembly pre-comp, here are all my passes that I rendered out. What I like to do first is organize them by separating the info passes from the passes that can reconstruct the beauty pass. So I'll fast forward through that. Okay, so the purpose of rendering passes in the first place is if you want to change the color of a specific object, for example, in your render without re-rendering out another render or possibly messing up the image itself. So in this case, I rendered out a pass for the cloth pattern as well as the bottle so I can easily manipulate those colors. To do that in this case, I'm going to come down here to my info passes and take my cloth matte RGB pass and place it on top of the stack. Then I'll add an adjustment layer and call it hue. Then I'll take the pick whip from the adjustment layer and pick whip this layer to the cloth matte and then switch this to Illumimatte. Now, one mistake I made here was rendering out the bright spots of the pattern as white and the others as black when I needed that white part in the part where I needed it to be white so that color can be changed easily through the matte. So what I ended up doing is pre-comping that hue and matte layer changing the color in this comp, and then going back to the main comp, taking this cloth mat here and pick whipping the pre-comp to this mat. I know that may have sounded and looked way more complicated than it needed to be, but since I made that mistake, I had to do a workaround, and hopefully that wasn't too confusing. And honestly, from there, as far as the colors of the cloth is concerned, it's just a matter of changing the hue, and now you should be able to render out multiple variations of this render without having to re-render anything, which is nice. So here is the final result, and there are tons of possibilities with working this way, and I hope this helped you in some way for your workflow. Thanks for watching.